Welcome back. In this video, we will learn about ionic charges. In the previous video, we learned that atoms have positively charged protons and negatively charged electrons. In fact, an atom will always have the same number of both of these particles, resulting in an overall neutral charge. However, because electrons move around the nucleus, it's actually possible to gain or lose one or more of them, resulting in what we would call an ion. As electrons are negatively charged, losing them will actually make for a positively charged ion, what we call a cation. Gaining one or more electrons will result in a negatively charged ion called an anion. Please note that the number of electrons gained or lost will affect the amount of negative or positive charge on the ion. However, all positive ions are cations and all negative ions are anions, regardless of the magnitude of the charge. You should also recall that metals tend to lose electrons. Thus, they form cations. For many of these metals, we can actually predict the number of electrons that will be lost based on their group. All group 1A metals, the alkali metals, will lose one electron and become 1+ cations. Hydrogen in the same group can also lose an electron to become 1+. The group 2A metals, the alkaline earth metals, lose 2 electrons and become 2+ cations, while aluminum in group 3A is going to lose 3 electrons to become a 3+ ion. These ions are all named simply by adding the word ion after the name of the element. Let's start with sodium. Of course, sodium has the elemental symbol Na. We can have the sodium ion. Since sodium's in group 1A, it will have a charge of 1+. And the charge is just written in the upper corner there. A lot of times, though, the 1 is going to be omitted, and you will usually just see it written Na+. While we're here, let's think about the names of the other 2 cations that have the same number of electrons as our sodium ion. Well, the sodium ion has an atomic number of 11, and that's also going to be its number of protons, 11 protons. Since sodium ions have a charge of +1, they're actually going to have 10 electrons. How do I know this? Well, because the number of protons minus the number of electrons equals the charge of our ion. Well, we can still keep the same number of electrons, 10, and have another cation. Well, a cation has to be positive, so it's going to be +2. Working backwards, we can see this should have 12 protons. The atomic number 12 is magnesium. And our magnesium ion is going to be Mg2+. Keeping on with 10 electrons, a cationic charge of +3 is possible. This will have 13 protons, and that's going to give us the element aluminum. So our aluminum ion, Al, 3+. While we're here, what's the charge on the calcium ion? Well, calcium, elemental symbol Ca, is in group 2A, so it's going to lose 2 electrons and have a charge of 2+. Many metal ions, usually our transition metal ions, can actually have more than one possible charge. Iron ions commonly have charges of either +2 or +3. In these cases, the name of the ion must specify the charge, writing it in Roman numerals between the name of the element and the word ion. For example, if we have Fe2+, this is the iron 2 ion. while Fe3+ is the iron 3 ion. We can switch to another metal. Mn4+ is a cation. Well, Mn is manganese. So this is actually the manganese. 4 in Roman numerals, IV, ion. Continuing, we can go all the way up in manganese to a 7+, giving us the manganese 7 VII ion. Sometimes these ions have historical names associated with them. In some places, iron 2+ is called ferrous, while the iron 3 ion is known as ferric iron. You don't actually need to memorize the historical names of any ions, but I wanted to make sure you were aware they do exist. The charges of transition metal ions are given in most cases by the name with the charge written out as shown before, and do not follow the simple rules like the alkali metals and alkaline earth metal ions. However, there are 3 common exceptions to this rule. They are zinc and cadmium, which both have charges of 2+, and silver. Remember, silver is Ag, which always has a charge of 1+. Now, just because zinc and cadmium are 2+, this doesn't work for the entire group. Below zinc and cadmium is mercury, and mercury ions can actually be 1+ or 2+. While in the same group as silver, copper ions can be 1 or 2+, and gold ions can be either 1+ or 3+. Additionally, tin and lead are not transition metals, but they can have different charges, either 2+ or 4+, so their charges need to be specified in their names. Moving away from our metals, nonmetals will actually gain electrons when they form ions. This is going to give us our anions. The pattern for naming anions is straightforward because each group will always have the same charge. The halogens in group 7A will gain 1 electron and become 1-. The chalcogens in group 6A will gain 2 electrons and become 2-, while the pnictogens in group 5A will gain 3 electrons and become 3-. This pattern shows us that all nonmetals will gain electrons until they have the same number as the next noble gas. Even though hydrogen is a nonmetal, it only rarely forms anions. You should remember that hydrogen is often a cation, 1+, but sometimes it will gain a single electron, giving it a total of 2, just like helium, its next noble gas. This means that hydrogen is a special case that can be either 1+ or 1- ions. The anions are named differently than our cations. In order to name an anion, we're actually going to remove the suffix and replace it with the ending "ide," that is IDE. For example, Cl-, the ion of chlorine, is called chloride. Oxygen in group 6A will become O2- as an anion, and this is oxide. H-, the anionic form of hydrogen, is called hydride, while H+ has a different name. It's named like all the other cations, the name of the element, hydrogen, followed by the word ion. Finally, we can work from the name the other direction. What is the charge of phosphide? Well, the IDE ending tells us we've got an anion. The element is phosphorus. Phosphorus is in group 5A, and the charge will be 3-. All of these ions that we've covered in the video are known as monatomic ions, as they all come from individual atoms. There will also be polyatomic ions that we cover in the next video.